As you probably know by now, Dynatrace isn't just a storage mechanism for telemetry. Dynatrace also builds a live, real-time topology model representing things such as hosts, processes, services, and applications. We call this the Smartscape. It's the live landscape of your telemetry producing entities. Now, for a long time, this model was relatively fixed and inflexible, with the main entity types being hosts, processes, services, and applications, and that was it. However, with the new capabilities of Grail, we've expanded this to be even more flexible. We call this new version the Smartscape on Grail, and in this video I'm going to walk you through how to use this new capability. So there are fundamentally three things you need to know to work with Smartscape on Grail. Nodes, number one, entities, number two, and signals, number three. So what is a node? A node is a monitored thing. It could be a physical thing, like a host, or a logical thing, like an S3 bucket. Nodes are where telemetry signals, that's logs, metrics, traces, and events, come from. Nodes are created in Dynatrace when you ingest open telemetry, install the one agent, install the Kubernetes operator, use an extension, or integrate with a cloud provider like AWS. Now, a node is mutable. So, for example, you might increase the amount of RAM in a host, and thus the node metadata will be updated in real time to reflect that new RAM value. Typically, nodes have relationships to other nodes. Edges connect nodes with a relationship. For example, a disk node belongs to a host node. An AWS EC2 instance runs on an AWS availability zone and is attached to an AWS EC2 subnet, and so on. These relationships are the edges. However, not all relationships are known simply by looking at the configuration. Some of these relationships only emerge at runtime and in real time. Think of a web request flowing through the system. The request might hit the front end first, and then a set of microservices on its way to the backend database. So because that happened, we can infer that those microservices are connected. In other words, the front-end service calls microservice A and so on back to the database. Now, when an edge is determined via the static kind of configuration, as in the host and disk example, we call that a static edge. When an edge is determined at runtime, we call that a dynamic edge. Dynamic edges are relevant to that particular time period. For example, if you update your architecture so that after a release, the front end no longer calls checkout, but instead calls a new service called validate payment details, you wouldn't want Smartscape to be kind of stuck with the old relationship. So if you query Smartscape yesterday, it will show correctly the old relationship. If you query Smartscape tomorrow or after the release, it will dynamically and automatically update to show the new architecture. Nodes and edges are only stored in Grail for a limited amount of time. Nodes have two timestamps: lifetime.start, which is the time the node was first seen, and lifetime.end, which is the time the node was last observed. Now, all data is stored for 35 days after the last lifetime.end update, meaning an entity and its relationships will remain indefinitely as long as it is regularly observed. Now, after 35 days of not seeing an entity, or more accurately, the entity not being updated, both the nodes and the edges are removed. So, for example, if a host is continually observed, it will last in the system forever. But if a host has no monitoring data or no updates for 35 days, then after that 35-day period of no updates, it's going to age out of the system. Okay, enough theory. Let's get hands-on. So first, I'm going to get an overview of what's available in our environment. For this, I'm going to use the Dynatrace Playground. You can follow along and access it too at playground.apps.dynatrace.com. When I'm in the Playground, I can search for the Smartscape app by pressing Ctrl and K and searching for the word Smartscape. Once you're there, you're going to notice a few pre-built views that focus on specific things like an infrastructure-specific view, a service dependency graph, and an AWS specific view, with other cloud providers coming soon. Now, inside of each of these views, you can also define and apply segments which further let you filter down your environment. Now, if you do want to see more about the Smartscape app, check out the video above, which walks through this app in detail from Andy. I'm now going to switch to notebooks and show you how to query the Smartscape topology data in real time using Dynatrace Query Language or DQL. Now, the notebook I'm using, you can find too. It's on the Playground. Again, check the links in the video description below. So first, let's get a view of every node, every entity, everything in our Smartscape. Next, let's start making sense of that raw list, because there's quite a lot there, by categorizing those nodes into types. Now, let's show only the Kubernetes related nodes. Switching to the edges or the relationships between the nodes, let's count all of those in the environment. We can do that with the Smartscape edges star command and summarize by the count. Do the same thing as we did with the nodes and summarize the edges by their type to get an understanding of how things connect to one another. All Kubernetes nodes contain the full YAML definitions that you would find on the actual Kubernetes cluster itself. So imagine you receive a notification that a particular Helm release contains a vulnerability and you want to quickly assess the impact of that. Well, you need to show the number of pods that exist in your environment due to that certain vulnerable chart at a certain version. And that's actually quite easy to do with DQL, as you can filter pods by the relevant pod label because you have access to that underlying Kubernetes metadata. Now that field is JSON, so let's use Dynatrace Query Language, DQL, to treat that field correctly as JSON. We do that by, again, getting the Smartscape nodes for the Kubernetes deployment, parsing that object field, and actually parsing it into JSON. Now let's use that to look at the containers that are within a particular pod. Now let's use Smartscape to understand the relationships between the nodes by actually traversing the edges between the nodes. So we can start at one node, follow the edge down or the relationship, and then jump to another node and so on down the chain. In this case, imagine we want to know which services talk to each other. Now this is an example of a dynamic edge, one that only appears at runtime based on the traffic patterns we observe. Now, we don't know the types of relationships that exist between services, so we're going to ask Dynatrace to get us all of the Smartscape edges where both the source type is service and the target type is service. In other words, Dynatrace, please show me what relationships currently exist between my services. Now that's useful, but notice the DQL returns the service IDs by default, and since I'm a human, I kind of want the human readable service name so that I can actually understand which services are which. I can use the getNodeName function to look up the service name using its ID that I do already have. I do that twice, once for the source service name and once for the target service name, and I add those both as new fields to the record. Finally, I choose to retain only 3 of the fields: the source service name, the target service name, and the relationship type. By reordering the columns, I can start to understand which service is talking to which service based on the real-time telemetry span data that's in Dynatrace. Now let's find out which Kubernetes deployments talk to each other and whether they are in the same namespace talking to each other or they are actually cross namespace. Notice here that we're again traversing the edges, but we can specify a direction because relationships exist in one direction and we can actually traverse backwards or forwards along the edges. Switching gears to security now, imagine we want to discover whether there are any AWS IAM role reuse across different lambdas. AWS, just like Kubernetes, does have its raw JSON configuration in Smartscape, in Dynatrace, which is accessible via DQL. So we can retrieve the AWS Lambda function nodes and then parse their JSON configuration to retrieve the IAM role name and then count the Lambda functions split by the IAM role. So there you have it, a small sample of the questions you can ask and the answers that you can get using Dynatrace Query Language with Smartscape on Grail. Smartscape on Grail will, of course, continue to expand over time with new node types and edges being added in the future. As always, I hope you found this useful. You'll find all of the links in the video description below to the playground and the dashboard and all of the sample DQL. So I recommend heading into the playground to experiment with Smartscape on Grail. I'll see you again very soon. Bye.